Hello everyone. How is everyone doing? I'm really excited to be here on this stream because this is my first time streaming for Global Hack Week. My first time, of course, streaming for anything MLH, and the first time on this side of the stream. I am really excited. How about all of you? How was your time spending and watching Ashwin with that awesome part two of Kubernetes? How did you feel about that? I see a lot of haze coming in. Nishit, hi. And this is also my first time using StreamYard, so you might see me getting a little confused here and there, figuring out what should be done and what not. Bear with me on that. We are going to figure this out together. Hi, Nishit. Hi, Shubham. Hi, Shivendu. We have, I'm quite not sure how that's pronounced. I'm going to call you Jay. Hi, Jay. Hi, Ace. Hi, Wani. Shubham, you should definitely do that. You should definitely give that a watch. That was an amazing stream right there. We give it a couple of more minutes for folks to join in. I'll give you that time to go check in. Here's the link on your screen. Go check in, be eligible for swags. And while you're doing that, I'm not sure if the other MLHs have told you this already, but while all the MLHs meet here for a call for a daily stand up every day, we have something called as the highlights that we share with all of the other teammates on our team. So the highlights is basically sharing anything special that happened to you after work yesterday or before you came in for work today. Let's do that here as well. Would anybody want to share any of your highlights from yesterday or today? It doesn't really have to be related to Global Hack Week particularly, but I see Alvin also on the stream. Hi. Would any of you want to share your highlight from yesterday or today? It can be anything related to the streams that you watch, it can be anything related to your lectures from college, anything. Do you want to tell me that? For me, I think my highlight has to be coming on the stream. I've been really, really, really waiting to do this. But let's hear from all of you on the chat. I have my eyes on the chat, looking for some responses there. Oh, Nishit says, my exams are going on. I hope you're doing really well. Good luck with that. Who else do we have there? Share your highlights, can be your lowlights as well. Midlights are allowed too, if that's a word. We'll give it a couple of more minutes to see if we have other friends joining in, and then we'll get started. Just giving you a quick overview while your highlights are coming in the chat. We're going to talk about very basics of blockchain. We're not going to complicate it a lot. I'm going to make sure that it's very simple to understand. You've already had opportunity to go through one of the streams by an expert from Solana. You did a little bit of tour of the Solana basics. You have another great stream coming up, I think, in about 3 hours from now. You're going to learn a lot over there. But what we're going to do here is we're going to learn very basics, unravel some terms that you have been hearing of when you hear of blockchain, understand what those things are without writing code. We're just going to depend on plain text and some of these interactive demos that are available online. And of course, ChatGPT 3 has been in the talks recently. We're also going to ask ChatGPT 3 some questions to see what that's going to look like. Let's see if our learnings match with what ChatGPT knows of. I am seeing a lot more highlights come in. Someone says, I'm currently learning trusses. I learned how to use CyberChef for forensics and malware analytics. That's really, really, really good. If you're into CTFs and all of those things, there's a website called Hack the Box or Hackerbox. I'm not quite sure. I think it was called Hack the Box. You should definitely check that out. They have awesome CTFs lined up there. And I think they also have the environment set up there. You don't really have to do all of those on your system. I'm quite not sure, but you should definitely check that out. There's Shubham saying, I haven't attended the Solana stream. Will that affect it? Not at all. We will consider the Solana stream as level 1. What we're going to do here is level 0. And towards the end, if folks who have watched the Solana stream already have questions, you can uh, shoot that on me, but I'm not quite sure if I'll have answers, but we'll figure that out together. We will do some great Google searches. I'll also be sharing some Google search tips that I feel all of you should know, because Google search is an art that all of us should learn at some point. We'll do that together. So Shubham, you are totally taken care of. There's no need of watching the Solana stream, but I'd highly recommend after we're done with this, whenever you get time later, because everything is recorded, you can go watch that stream, both the parts. We have a second part coming in today, and get a lot more knowledge of what Solana is. And then there is Nishit telling us, Nishit was around for the Web3 session yesterday. That's great. That's very great. And we have Jay telling us, Hack the Box. Yes, that's what it's called. They just completed the university CTF. Advent of Cyber 2022 is also going on. Try acting great for CTFs. Absolutely. I love that platform. Cool. I think we waited enough. We'll probably go jump right into it. Let me bring my slides up. We'll have a mix of slides and then demos and then some bit of writing on Excalibur, some shout outs to great open source projects that we're going to use here. A lot of that in the next 1 hour, probably. That's most we'll need. We have another hello coming up from, I'm guessing, Vansh. If not, I'll call you V. Hi, V. Cool. Let me get this to the stream and we will get started. I hope you have that visible. Let me just quickly check if you can see me. Yes, looks like we are all good. So you might already know that this stream, we're calling it blockchain as a piece of cake because we wanted it to be really, really beginner friendly and we wanted to be as simple as you would eat a cake or make one. We have a lot of highs coming in. Hi to everybody else there. To introduce myself, I am Siddharth. I am a first party events coordinator at Major League Hacking. I go by the pronouns he, him. And a fun fact about me is I love airplanes. I did try to make a background for myself, a virtual background with a lot of airplanes, but it turned out to be a disaster. But most probably for the next Global Hack Week, whenever you see me, you're going to find me with a lot of airplanes on my background. And if there are other fans of aviation, not just airplanes, but aviation in general, drop your aviation history there. Oh, I see someone saying I'm the second Sid. That is correct. And interestingly, both of our spellings are the same. So internally, we call ourselves Siddharth D. That's the Alwal, or he goes by the name Sid from MLH. And then I keep myself as Siddharth S or Siddharth from MLH. But we have the same spellings. Kudos to you for finding that out. But I think there are no aviation fans in the chat. Are there any? Giving that a second. Hey, hey, hey. We have Nishit joining in on YouTube telling us that developers developed AI and now AI is replacing developers. That is correct. I can 100% agree on that. But you probably will need more of AI developers going forward. So that's again a win win, I'd say. But yes, completely agree. ChatGPT is surprising us every day with what it can do. And I'd probably also show you an interesting tweet that I came across today, wherein a person is trying to ask or fetch SVG codes out of ChatGPT. ChatGPT. I'm sorry, I don't know why I keep calling it ChatGPT 3. But for the first time, ChatGPT tells the person that it does not understand what SVG codes are, and then this person tries to make ChatGPT learn what SVGs are by giving it examples of a couple of things. And then surprisingly, right after I think 2 or 3 examples, ChatGPT produces SVG codes by its own. It's able to create shapes by its own. That's fantastic. I'll probably show you that once we go ahead in the stream. But quickly going on to what we're going to do on the stream, we'll keep it to the basics, only to the basics. But before we get started, if you have any questions, feel free to drop the questions in the chat. I have my eyes on the chat. We'll make sure that we don't go very fast here. We'll make sure that both of us, all of us together, are learning this very, very well, and then proceed to other complicated things later. And because I'll say I'm going to be a pilot on this slide, I'll make sure this has no turbulence for you. Whenever you feel anything, just drop that in the chat and I'll come back to help you with that. So the first thing that we're going to talk about, or probably this thing that you always hear of, is decentralization or a distributed atmosphere. I'm sure you've heard of all of those terms when you talk about blockchain. And I think it would only do justice if we start talking about what these things are, what do these mean, how do they differ, and what are the pros and cons of it. We're not yet there to actually derive why blockchains have been built on a decentralized or distributed fashion, but we're just starting with a plain comparison of all the three terms. Let's get into it. Starting with what we call as a centralized system. As you can see in this image right here, all the nodes, we'll call all the black dots that you see on the exterior a node, and all the nodes are connected to a center point where you can see all those lines meeting. And in this diagram, they call it stations and not nodes. You can use either of the terms, whichever you feel is friendly for you. And all of these stations or node are connected to the central authority or the central server, we can call it anything there, with a link. And what this is trying to show you is whenever it's a centralized architecture, there's complete resilience or complete reliance on a single point. Can you think of some pros and cons of what could go right or wrong if you have a structure like this? Let's start with the cons. Can somebody tell me what can go wrong if we have a system designed like this? For example, let's say there's one server that I have running and there are multiple clients that are connected or multiple computers that are connected to this server. What do you think can go wrong in such a architecture? Would you want to tell me that on the chat? Oh, I see somebody saying collisions. That might happen if you have a lot of packets coming into the same place. You might experience packet collisions and packet losses. That is true. Shivendu is telling us that it's going to be very unstable. That is also true. I believe you're saying it's going to be unstable because it's all relying on a single point, and if that point doesn't perform as we expect it to, it's probably going to be a very unstable scenario. You were true there. And that was Jay telling us about collisions. We have it's Nishu telling us if any tragedy happens to servers, then not having backups or not having replacement servers, our apps could go down. That's absolutely correct. That's actually what is going to happen here. So as all of you rightly pointed out, the cons here as it's prone to failure. It's as if it's made to fail. You also will have longer access times to data for users who are far away. If you've ever used cloud infrastructure, this is not something that you should be knowing to go ahead in the stream, but if you've ever used cloud infrastructures, if you've ever tried out any of the cloud services, you might have seen whenever you're trying to spin up a service of any kind on a cloud infrastructure, they ask you to select a region that's geographically the closest to you. And this is the same logic here. You'd want the servers and everything to be very close to you or your customers, so it services you very, very, very quickly. Those are definitely the cons. And talking about the pros, it's really simple to deploy this for obvious reasons. You don't have a lot of complexities here. You have a server, everything else gets connected to it, simple and easy peasy. It can also be developed quickly. As you can guess, that's not a lot of complexity, so it's always easy to develop, affordable to maintain, because there's just one server that you need to maintain, not multiple copies or replicas, nothing of that sort. And this might be an ideal situation to have when you have data that needs to be controlled centrally. Let's just imagine that you don't want data to be going out anywhere. This is just a personal private permission server that you're trying to run, where you don't want anybody to come and do anything of any activity of any sort. You just want to keep it to yourself, just using it for your let's say you're setting up a home automation server for yourself. You want just your devices, your mobile devices, your laptops and those things to connect to the server and communicate. There's nothing that you're going to lose out even if it goes down, right? So it's in that case very simple for you to develop. It's going to be cost effective. You don't really have to spend a lot for maintenance, and of course you are the one who's controlling it, so it's easier for you to control it from one single center point. Moving on to the next architecture here, we're going to talk about the decentralized architecture. Decentralized, as you might have guessed, or by the name it says it's not centralized, wherein it means while we were learning about the centralized architecture, we saw that all of the control, or probably the overview of everything, there was one single center point wherein the reliance was completely on. But here you will see multiple of those coming into picture, there are several server like, or there are several owners, I would say. I have another question here. I'll just quickly jump into that. Nishit asks, what is the first step to start learning Web3? The first step to start learning Web3 is to get yourself, in my opinion, that's how I started. So get yourself accustomed to the terms that you're going to hear of, exactly what we're doing here. Once you have the idea of that, you're probably going to now learn of different algorithms that go into it. We'll talk about that very briefly moving on. And then you go further to learn some kind of blockchain technology, Solana being one that you learned about yesterday. And that's how you progress. You go on to building decentralized applications and you keep taking that path. I hope that answers your question. Going back to what decentralized networks are, you have multiple points of coordination over here, and you're not really dependent on one single point, which, when failed, will not have any kind of adverse effect here. You're able to manage still because there's not everybody getting connected to the same central point. So here it's likely to fail, but when compared to a centralized system, better performance, of course, allows for more flexibility, as you can always see. The cons of it here could be security and privacy risk as well. So let's just say that there is one node at the very exterior corner who would want to communicate to the central entity, but they have to go through another secondary server of sorts. So they are not just sending the data directly to where they wanted it to be, but they're sending it through a secondary node essentially. And that might create security and privacy risk if not handled correctly. It doesn't mean that there's no way to ensure a private and secure connection. But if you're not able to handle that very well, that might create a little bit of trouble. And I think this will be a good example to give out here. I don't know if all of you have heard of a social media called Mastodon, which has picked up pace very recently, which is again an open source project. I'll just give you a couple of minutes to tell me if you have been using Mastodon. If you have, you can probably tell me why do you like it, why do you like being there. Or you can also drop your username from Mastodon so you can find other friends and everybody here can go and connect with you. Anybody here who has been using Mastodon? Indigo Wizard says, read about it, sounds interesting, but I haven't tried it though. You should definitely try it out. Not trying to vouch for Mastodon, but I'm someone who loves open source projects and I would really want to advocate for open source projects, whatever they are into. So this is one open source project, which again is free as well. And they've implied a decentralized structure. That's how they call themselves. So you should definitely go and try that out. I have Shubham telling me, yes, I tried it since everyone was afraid Twitter would be shut. Haven't scrolled a lot. Cool, that's nice. I would say rather than being just a user of what the platform has to provide to you, you should definitely go check out the GitHub repository since it's completely open source. Let me just link all of you to it. You can go do it. And then we're also going to create a rule here, which is I'm going to give a shout out to a lot of open source projects while we're going to talk about Web3. And then every time we do it, we're going to go give them a star on the GitHub repository to show some appreciation for the awesome work all of them have been doing. And in case you consider tweeting or sharing on any social media platform about this stream, go tag their pages as well and thank them for whatever they are building. So I'm going to just drop the link to Mastodon because that's the first project we talked about. That's there. This is the one I was talking about. Go check that link out. And I was saying it's very good to be a user, but you should also go check out their code, check out what help you can provide to them. I'm sure there are a lot of things that you can help them with. I am looking at the GitHub repository right now, and I can see there are about 3,000 issues, more than 3,000 issues that they've labeled. And it'd be really, really, really nice to have all of you go help them. And it also helps you improve your skills, honestly. Consider doing that. And then somebody is telling me apparently, oh, Jay is telling us, I tried using it. Apparently, the InfoSec community is booming there. I am not really sure. I'm not someone who's logged into that platform yet, but I'm keeping a close eye on their GitHub repositories to see everything that they are trying to achieve there. So if you've visited their GitHub profiles, the GitHub repositories, and given them a star, drop a thumbs up so I know all of you are supporting them while you're watching this stream. While all of you are there, giving them a like, I'll give you a couple of minutes to do that. So cool. Thank you so much for doing that. I have Ace who's given me a thumbs up. I have Shubham who's giving me a thumbs up. Jay again, be super active, giving me a thumbs up again. Indigo Wizard, thank you so much. Pratami, thank you, thank you. And it's Nishu, thank you so much. Bunch, all of your great audience. Thank you so much for that. We're going to go to our next system, which is now the only one remaining that we need to talk about, which is the distributed systems. Distributed systems, I'm sure you've noticed the difference between the diagrams, and this kind of reminds you of a peer-to-peer system where almost every peer is connected to everybody else. And a line to explain this would be that every node collectively executes a task, wherein it means that whenever there is some kind of a decision that you have to take here, we'll talk about decisions and consensus a little later. But just have this in mind. Just make a note of this, that whenever there's a requirement where you need to make any kind of decisions, a distributed system will allow every node or every member of this network to take part in it. So it's a decision that's been taken by the majority essentially, and not just one single owner or a couple of owners, whenever or whatever your network looks like. Talking about the pros, of course, a lot more fault tolerant, transparent and secure, because you have majority of them taking part in it. But yeah, if you would want to say that if the 51% or more than the majority of folks or members in the network are corrupted, want to do something mischievous in that network, they can definitely do that, and the network will collapse because they are a majority there. But generally that might not be the case. So every decision that's been taken in a mesh like structure that you see on your screen right now, it's going to be secure, a lot more secure and a lot more transparent. Of course, it's also extremely scalable for obvious reasons. The cons will be it's more difficult to deploy and take care of, because you can imagine how complicated this can become when you have a lot of people coming in. You need to get them connected to probably a lot of peers who are close to them. So that can get a little bit of complicated. That can get a little complicated while you're trying to build or deploy it, and also will have a little bit of extra cost on you while you're trying to maintain it. I have still have thumbs up pouring in. Thank you so much for all of those likes, all of those stars. I mean, so that's a brief about centralized, decentralized, and distributed networks. I hope we are able to understand what those basically mean. Nothing complicated there. But now we're going to talk about another concept which is very important, which is called hashing. Before I start talking about hashing, I just want to tell you that this might sound a little complicated, but we're going to take up a very easy example and talk about what and why hashing is important here. So hashing falls under a category or a subject under computer science, which is called cryptography. Cryptography is essentially using a lot of math, a lot of problem solving skills to encode your message or decode your message and give it a special meaning wherein the message itself in its natural form isn't visible. Let me now go back to another great open source project. I did not plan to do this, but I can see open source projects are helpful everywhere. This is called Excalidraw. I am not sure if you know of Excalidraw. Excalidraw is again an open source note taker, hand drawing tool kind of a thing, which has several things that you can do. Requires no login, requires no fancy complicated sign up mechanism. I am going to drop their link, the GitHub repo link, again on the chat. It would be nice to have all of you go support them if you would like to. Here is the link on the chat. Cool. Coming back to hashing, let's just make this really simple. So we're talking about hashing. And hashing, like I told you, oh, Nishu likes and loves the app. I see. Best note taking app ever. Completely agree. And a lot simpler too. You don't really have to do anything complicated to make sure it's working. So talking about hashing, we're going to take a little bit of assumptions here, but you will understand why we did that. So we're going to assume that we have a function Don't get scared. I'm just doing this so it sounds fancy when you take those screenshots and show people what you've learned. But let's just imagine we have a function called fx, wherein x is a number that we give it as an input. Let's just write x is a number, and what so x is a number, and then the output of the function, or whenever you provide x into this function, the output is going to be x rounded to the nearest multiple of 10. Let me give you a few examples. Let's say x in this case was 5 or 6, let's say. What do you think is going to be the nearest multiple of 10 for 6? And that's, of course, going to be 10, right? Which is going to be the nearest. So what's happening here is we are trying to use a function to map an input to an output, wherein looking at the output, you will not be able to guess what the input was. And it's always a one-way function, which means you give it an input, it'll reach an output. You can never give it the output and then have it reach the input. So it's always a one-way function like that. The other thing here is the inputs, if remaining, uh, sorry, what I was trying to say was, if you keep the inputs constant or the same, you will always get the same output, which means if the first time I give it an input of 6, it'll give me an input of 10, and that will happen as many number of times I give it an input of 6. Now, taking another example, let's just say I take an input of 17, or let's say I take an input of 12. What do you think this is going to round me off to? Does anybody want to take a guess? What we're trying to do here is we take an input number and then we're trying to round it to the nearest multiple of 10. Oh, I see a lot of responses. All of you are correct. Ace, you are correct. Aki, Iqbal, I'm sorry if I'm getting that wrong, but I think your second name or first name is Iqbal, so I'm going to call you that. We have it's Nishu saying 10. We have Nishit saying 10. Sai Float saying 10. All of you are amazing and correct here. It is indeed 10. So that explains to me that all of you now understand the general concept of what we're trying to do here. But talking about how this is utilized in a real world scenario, it's not going to be this simple a function. It's going to be complicated ones. You will hear of algorithms such as MD and SHA. SHA is secure hashing or hash algorithm, and MD is supposed to be message digest. So all of these algorithms have different hashing functions that they make use of, and you will definitely have different outputs coming out of it, right? Now you will not see these algorithms mentioned in this way, but you're going to find them mentioned as a combination of these alphabets along with certain numerical terms or numeric or some numbers right next to it. So you might find SHA-256, you might find MD5. What does those mean? We have a lot of highs coming in. Hello, hello, hello. Going back. So talking about what these things mean over here, these denote the number of bits that the output is going to have. To explain that, let's go back to another awesome website, which is again open source. But I'll just write this down that 256 denotes the number of bits in the output of the hashing function. And in case you're confused what bits mean, bits smallest, a bit is the smallest storage unit of a computer, and 8 bits from 1 byte, and all the MBs, GBs, terabytes that you know of are all larger greater terms of bit. So larger terms of a bit. Now we're going to go back and see hashing work for real. This again is a website that you should definitely check out. I will drop the link of this together very soon. So what you see here, zooming in a little bit, is a website which has a space for us to write down some data, it generates the hash automatically. And on the top, it mentions that it's using the SHA-256 hashing algorithm, which means there'll be 256 bits in the output, which here what you see is a 256-bit output. And SHA, again, like we already discussed, it's the algorithm that's being used here. So what we're going to do here is we're going to provide it with, while it's empty, you already have a hash value there. But let's just try and say, hey, this is the GHW demo, and you will see the values changing accordingly. What's happening here is every time I put in a data or a string over here, it doesn't really have to be a number. I was just giving you an example of a number there. So it's easier to understand, but you could have any kind of a string going into it. And while you give that input, it's going to generate a hash. It's really simple, really easy to import these hashing algorithm libraries and then form or get the hashing values out of it. But the point that we need to note here is whenever you make even the slightest change to the input data, the hash is going to change tremendously. That's also, this property is also called avalanche effect. Let me just Google search and show you what that means. So we're going to do avalanche. We misspell that, but we see avalanche over here, which doesn't really say what we're trying to do. So we're going to say avalanche cryptography. Here it is. This says the term is associated with a specific behavior of mathematical functions. Oops, not logging in this time. Right, a slight change in either the key or the plain text should result in a significant change in the ciphertext. Ciphertext here is the output. So what we're going to try and doing here is we're going to go back. We're going to just delete this small full stop that you see or a dot that you see. We're just going to remove that, and you're going to find the hashing result change tremendously. Let's just make note of what we see right now. It starts with a 36E, ends with a 9F3. And then when I delete this, this has no correlation with what was there earlier. So there's no way for anybody to figure out, for anybody to do a brute force attack very easily and figure out what your uh, input was. They can definitely brute force, but there are exponentially a lot of inputs that they would want to try out. That makes hashing very, very secure. And there's no way for anybody to figure out what the input was. This was the first complicated thing that we had to deal with. So I'm going to take a little bit of time to see if anybody here has any questions, or if you are all good, drop a thumbs up, tell me there's no turbulence, send me sunlights, no clouds, anything of that sort, and let me know if you have been following. Waiting for all your replies. We have thumbs ups coming in. Just to confirm. We also have Shubham dropping in another link. I'm sorry, Nishit dropping in another link where you can try out SHA, and not just SHA, a lot of other hashing algorithms. Thank you so much for sharing that. That definitely is a great website. Then Shubhamas, just to confirm, the message cannot be retrieved from the hash, right? It cannot be retrieved directly from the hashes. If you want the messages to be stored separately somewhere, so you have the hash along with the message being retrieved at the other end, you will have to have another mechanism where both of these things go together. There'll be no way where you can just pass on the hash and have that help you and retrieve the input. Rafi is asking me if I'm too late. You are not at all late. We just completed a couple of terms here, which you can always come back and learn more about. And to be honest, not all of the terms are related to what we're going to learn next. So you're good. I see a lot of thumbs ups. Really, really happy to see them. And then Nishit trying out, I think you're trying out some kind of hashing. Should be that, I guess. And then another thumbs up. Nice, nice, nice. Okay, another thumbs up here. Oh, this is a nice question. So someone asks, I'm going to call you M because I don't know how to pronounce that name. Salting and hashing would be more better, right? I would say yes, but since we're not trying to complicate things, we're trying to keep it simple. We're not going to talk about what salting is over here, but yes, that is something that you pointed out correctly. And if anybody is curious about what salting is, you should definitely go just Google it about it. But we're not probably going to cover this here. There's another chat which says, is there any way to convert the hash to the original data? Not that I know of. I don't think that's possible because the whole purpose of hashing your message is to make sure nobody is able to retrieve that data, the original data from the hashes. So, no, that's not something we would want to happen. Cool. Looking at the chat, I think we don't have other questions. Let's go on to the next one. Cool. Now we're going to talk about ledgers because any definition of blockchain you check out, you're going to find that they all call it a ledger. A ledger in simple English is just a book or a digital record that has a lot of financial entries in it. So this is the same over here. It's just a record of a lot of digital transactions that's going to happen. Transactions can be anything. That's something that you would want to note over here. In case of blockchain, a transaction can be you deploying your code onto blockchain, you running your code or script on blockchain, or of course any kind of monetary transaction that happens. So any kind of action that you perform on a blockchain will be considered a transaction. And because there is a concept of transactions here, that's exactly why you find a concept of cryptocurrencies being native to blockchains. And that's again a different story when these cryptocurrencies are tradable and you're buying it, selling it, and it's pegged to a fiat currency. All of those things is completely different. But just keep in mind that the concept of transactions is why we also have cryptos or any kind of native currency associated to a blockchain platform coming in. Cool. Simple, easy peasy. Let's go to the next one. This is where we're going to talk about consensus. If you remember, we talked about a decision making process while we were talking about the distributed architecture of things. And this exactly is where consensus or decision making is very, very, very important. So when we were on the slide, which was showing us all the different peers connected to a single uh, distributed system or a distributed network, in this network, there were several peers or stakeholders who were trying to be involved in the decision making process, and that always will ask for an algorithm that's going to decide who's the winner, or who or what decision should we be finally taking forward or going forward with. So you will find a lot of mentions of consensus algorithms. Proof of work, I am sure all of you have heard of it. That's the first, probably the oldest that all of us know about. That's what came in the first Bitcoin paper as well. You probably would have heard of proof of stake. We're not going to talk more about that because these are different algorithms that have been set in place for different use cases, for different purposes, or either to improve on what was already there. They've made a lot of changes. Researchers have made this happen. But this is going to be out there for your curiosity to find out later after the stream. But just for this, I'm also going to point out one other proof of Dash that you heard about yesterday during the Solana stream. If there's anybody who was there around in the Solana stream and you heard the speaker, the expert from Solana mentioned about a algorithm which started with a proof of a PO, and there was a third term in it. Can anybody guess what that was? Oh, and if you would want to Google search, that's completely fine. Everything is allowed. Nishit being very honest, saying no. Full marks for honesty. Shubham asks blockchain? Not really. Proof of stake? Not even that. Cool. I'll probably break the bubble here and say it was proof of history. You might have noticed in one of the slides that it said POH. That's another consensus algorithm, which probably goes in tandem with proof of work and proof of stake. But just mentioning that here, just in case you missed watching that stream, you can always go back. The recording should be on Twitch, also on YouTube. That's about consensus. Consensus is a decision making process where you need an algorithm that helps you do this. Now, what is a block? We've come far in this process to now reach what is a block, which will next lead us to what a blockchain is. We're not going to stick to any kind of definitions here for what is a block, but we'll just quickly look at what consists of a block, and we'll then talk about why do we think all of these things are interesting to have and important to have as well. So a typical block will have transactions, of course, because we've been talking about transactions. We also discussed that anything that happens on a blockchain is a transaction. So all of these transactions lastly have to find its way to a block, which here is, of course, demonstrated or depicted as a cube or a cuboid, but that's just to make things easier for us or our brains to imagine. And you'll also see a chain emoji in between just to give you a feel of blocks and a chain connecting them, but there's no square or cube or cuboidal structure there, but it will typically consist of the transactions that it should have. It will have the hash of the present block, hash of the previous block, and of course timestamps. So we already know what hashes are. We will discuss on why we need to have present and the previous block hashes a little later. Timestamps, I think it's self-explanatory. Whenever we are trying to do anything, we would want to maintain timestamps to know when this happened, and probably also want to log who did that, so we have accountability and we are able to trace back to what might have went wrong or right at the point that concerns us. To give you an example, let's just say while you're going to college or while you're going for work, you probably have to show your ID card somewhere, scan it somewhere, and that system will log saying this person XYZ logged in at XYZ time, did this over here, something like that. So just let's just assume that the timestamps are right now required for logging purposes. So transactions, and I'm not saying these are the only things that are going in there, but these are some things that we should be knowing of it right now. So transactions, hash of the present and the previous block, and of course timestamps. Now we are at where we should be. This is exactly what we were preparing for. This is not the last slide, but we are now going to talk about what blockchains are. I'm going to give you a minute to probably suggest what you think blockchains are, or instead you could also let me know if you'd want ChatGPT to answer that. If you'd want ChatGPT to answer that, we go share my screen, look at ChatGPT, ask ChatGPT the question, and then get an answer from that and verify if our learning is correct. But starting with, any of you want to share what you think a blockchain could be? Chain of blocks connected together. That's a very easy peasy explanation, but that's correct. Anybody else want to give this a shot? Waiting while I go log in to ChatGPT to see if we can go ask ChatGPT about that. Anybody else wants to take a dig here and try to make a sentence of what blockchain could mean? Nishit says it's a type of distributed ledger technology. Yes, because we already talked about distributed networks and ledger networks that completely ledger technology. I'm sorry, we completely know what those terms mean. And you say that consists of growing list of records called blocks. That is correct. We have Anshi saying blockchain is just a method which can be used in place of traditionally used ledger, but it will be decentralized. There'll be no central authority who's going to govern over data. I would say that's correct too in some sense. And then Nishu correcting the leader with the ledger, saying digital ledger distributed across some network. I would say all of you are a little correct, but let's go quickly and ask Chat GPT about what Chat GPT thinks. So we're going to do what is blockchain? Question mark. I'm going to ask ChatGPT about it. Zooming in a little so all of you can see it. ChatGPT probably wasn't ready to answer that question, taking some time there. I'm going to grab some water while we give it some time. Oops, looks like it's probably something to do with my network. Let me go back, get all of you to Excalibur and try refreshing ChatGPT. Or if any of you were able to go ask ChatGPT about blockchains and if you've been able to get an answer, drop that in the chat. Let's all look at what ChatGPT thinks of blockchains. Is ChatGPT an app? That's an interesting question. So ChatGPT for now is a web interface, has a web interface that you can communicate to it through. And ChatGPT is a product of OpenAI. OpenAI develops amazing AI products. ChatGPT is a text-related product wherein you type down some queries or prompts that are completely text and it gives back a lot of text-related answers. We have seen people go ahead and ask it to write code. We have seen people ask it to explain code, validate code. Possibilities are endless. The other famous product by OpenAI was DALI. I don't know if all of you know about DALI, but DALI was a text to image AI wherein you give in any kind of text, it tries to make sense of whatever you drop down and then gives you an image related to it. I think GPT doesn't want to work for me, but I have a couple of, yes, it says there's an error that occurred. No problem. We're going to go back to the slide and have, oh, I see a couple of people that have shared responses from ChatGPT. I am going to pick one of them and we're going to check if it makes sense to us with the words that we learned a little while ago. So, reading from what Ace shared with us, it says blockchain is a distributed digital ledger technology, makes sense with the terms that we just discovered, that records and stores data in a secure, decentralized, and immutable way. Okay. It is used to create a permanent and tamper proof record of transactions. Okay. Agreements, contracts, and other data. Blockchain technology is used in a variety of applications such as cryptocurrency, smart contracts, and supply chain management. Yeah, I think we were able to cover all of the or most of the complicated terms involved in there. Let's go back and check if ChatGPT has the same had the same answer for M as well. I'm calling you M. I'm sorry. So here it says blockchain is a distributed, decentralized public ledger that records the history of transactions across a network of computers. That makes sense. It allows multiple parties to securely record transactions without the need for a central authority or intermediary. Definitely true. Each transaction is recorded as a block on the chain. We did discuss that the blocks have transactions in it, so that's definitely correct. And once a block is added to the chain, it cannot be altered or deleted. That is something that we're going to figure out very soon. This makes the blockchain a secure and tamper-proof way of storing data. 100 points to what ChatGPT told us. All of that is definitely true. But I have a very simple and similar explanation here of what blockchain can be. And this is probably the simplest that I've found on the internet, which says an open distributed ledger that can record transactions between several stakeholders in a transparent, verifiable, and permanent manner. So, all of the terms here, I believe, are very simple. We don't really need to explain them. But what we're going to do here is we are going to actually watch all of this happening live. Let me show you another great website. I'm going to drop that link here because you might not see it while I'm sharing it. You might not see the URL while I'm sharing it, but we are going here to this website. We're going to skip the instructions because we have already discussed a lot of things about it. I am going to tell you what you see here. We've already discussed that we have data on a blockchain. We've already discussed we have a previous hash. We've discussed we have a hash. We have discussed that we have timestamp. But you also now see a lot of other numbers. You see something right here. Here you see Genesis written. Doesn't make sense, right? For that to make sense, we're going to go back and learn about blocks. Shout out to another open source project which is making it very, very, very handy to do this. Shout out to Anders Brownworth. Anders Brownworth has made a lot of these explanations, interactive demos of hashes, blocks, blockchain, distributed systems, tokens, Coinbase. You should definitely check that out. But we're going to first figure out what blocks are and how those function. We've talked about blocks. You probably can also guess why there's a block number, just to have a numerical numbering going on for each of the blocks that we have. And block height also refers to the maximum number of blocks that exist on a blockchain. So for now, you can see there's just one block, so the block height is 1. You have a hash, we've talked about that. We also saw how the hash would change when I write, hey, I am Siddharth. I am basically changing the outputs here, the data here, and you will see the hash changing. And you might have noticed while I was changing all of those things, what was in green now is in red. Now we're going to talk about what and why that happened. We have a hello coming in. Hello, hello, hello. Vinayak, thank you for being here. We have a thumbs up. I'm assuming you were able to understand what just happened. But for everybody else's discussion and knowledge, you will now see a term called nonce or nonce. You can call it either. This nonce is a number here which we haven't talked about. So a little bit of complication here, but we're going to make it simple again. So every time we have transactions coming into the block and a block being formed with all of the data that it needs, the metadata and everything, there's a process that happens which is called mining. And while I discuss about mining, some things that you're going to learn of right now might just be restricted to earlier blockchains, primitive blockchains that we are talking about. Things have definitely evolved a lot because of a lot of cons that existed with the primitive blockchains. Things have developed very, very, very quickly. There are always better ways to do these things now. But what we want to talk about is the process of mining, which will validate transactions in a block and add that to the existing blockchain. Now let's simplify and understand how this happens. Whenever you have a block being formed, there is a target hash, or a, let's say, a range of hash that you would need to reach. I know this doesn't make any sense for now, but we're going to assume that there is always a target hash that we would want to achieve. And every time a mining node, we're going to call it a mining node. Mining node again is a computer that's helping us with minings. Whenever a mining node is trying to validate the transactions and form a block and then have it as part of a blockchain, it has to achieve that target hash. Now, if you think of what things can change the hash, any kind of string that's in a block can actually change the hash. So while we were looking at hashes only, we discussed that change in data can change the hash. But the hash that we're looking at right now is basically the hash of the complete block. So what that would mean is any kind of data present on the block itself is contributing to the hash that's coming out finally. So you can say block number, nonce over here, data, all that put together is what giving us this hash. It's not just data that's giving us this hash. I hope that explains it. Now, talking about where nonce came in from. So these things, these fields that we talked about, which is block, data, timestamp, all of those things cannot be altered, because if you'd want to change hash and you would want to reach a target hash, the only way to do that is to change a number of things that are there inside of the block. But we know that transactions carry some kind of importance, so we can't change that. Block number carries importance, we can't change that. Data, of course, carries importance, so we can't change that. That's where we introduce this number that you see, which is called nonce or nonce. So what this nonce is going to do is the computer or the mining node is going to do a lot of mathematical computations to figure out this nonce, which is going to give us the target hash. So what you see over here is the nonce which existed while the data field was completely empty. But when we made a change over here, the node now knows, or the block now knows, that something went wrong. I don't feel like green. I should be green right now. I should be red because there's something wrong. Now, to make sure that we are able to make this correct again, you will see a mine thing here. What's going to happen here is, again, it's going to replicate that process of calculating a nonce that's going to give us a target hash. So I click on mine, and you will see the nonce changing and the hash changing as well. So now you notice it's now a new hash and a new nonce that we have, which fulfills the conditions that we would need for this block for the transactions to be validated and then finally be added to a blockchain. I know this was a little bit complicated than what we've discussed already, so I'll take a couple of minutes here to know of what all of you feel. I see a question which is what is nonce. I hope now you know what nonce is. We talked about it briefly. Anybody else would want to share their thoughts, would want to tell me if they understood what nonce is? Would you want to tell me if you found that really complicated? Any kind of feedback that you would want to share? I see comments. It says no and yes. I'm assuming that means you understand what's happening here, which is great. Cool. Awesome. Vinayak says, I know this block hash code changes every time we do something with this data. That is correct. Hashes have to change whenever there's change in data because the input is always any kind of data that you give it. It can be a combination of just the data field, or it can be just the data field, a combination of other fields that you see, which will finally give you the output hash. That is correct. Cool. We have another question here. Is there anything that is important for us to know about nonce if we just want to develop an app on blockchain? Not really. So the things that we're talking about right now is an explanation of how things work in the background, from a couple of blockchain platforms that I know of that I have been involved in developments of applications on top of. I can tell you that you don't need to worry about nonce as a field, but this is an explanation of what happens in the background when you hear of a word called mining, if you hear mining nodes, anything of that sort. But I think for the most part, you are safe here until you would want to set up a blockchain network for your organization and you're doing a lot of background checks. That's somewhere you would need to know of what's happening. But if you're just going on to build apps, you are good. I see. Okay, thanks. Cool. Now we know what blockchains are, we know what blocks are, we know what ledgers are, hashes are. A lot of hard lifting has been done, heavy lifting has been done. Now, a brief on what types of blockchain you can find out there. You can find a public blockchain, which is okay. I have another question here. We'll cover that and then go to types of blockchain. You have any website or YouTube channels to learn about Web3? Uh, this reminds me of what happened in the stream where Vinayak was hosting one of very popular faces in Web3 communities. And there was this question posed onto them, and they said, you just have to Google, it's just a Google search away. Just go Google Web3, you just Google blockchain, and you'll find a lot of resources. But I know it's very difficult to navigate through all of these resources and figure things out for yourself, which might be really friendly. Um, what I have been personally doing is not learning about Web3 on the whole, but I have a tab always running which is trying to teach me about Web3 on the whole. But you will always need other tabs which are going to explain a lot of things under it. So while you're learning about Web3, you will definitely come across cryptography or hashes. Now you will need to have other hashes, other tabs going on which would explain you what hashes are. So it's going to be a long process. I wouldn't say that you have a one-stop shop which is going to tell you everything about it. But I feel there is one that's going to give you that. I see it's an issue explaining DApp University on YouTube. That could be a great checkout. I've never tried that out personally. We have somebody saying Alchemy University. That could also be a great watch. I have not tried that out. I will definitely look up that as well. Cool. Thank you so much for all the help. Coming back to what the types of blockchains are, this is really simple here. Talking about public blockchains, a public blockchain is that which anyone can join and participate in. A very easy example of that is Bitcoin blockchain. Bitcoin blockchain is very easy to participate in. You just have to go create account, create uh, while the account there would mean you have to create an account on a wallet. We'll talk about what wallet is, and anybody can participate in that. You would see people investing in bitcoins and all of those things. It's completely open. Anybody can go and participate in it. The next one is called private, which again says it's a privately controlled thing wherein you can't really just go there and participate. There'll be someone who is in charge of making sure that not everybody is welcome into that atmosphere. There'll be some kind of uh, I would say a closed barrier in there. It wouldn't be public. That's what private would explain. Permission, again, you would need, it's also private, but you would need a special invite to join it. There's very little difference between private and permission, but I just wanted to put that across if you ever come across those terms. Then there's something known as consortium. A consortium is actually, by the name, it suggests that multiple organizations or multiple stakeholders come together and share the responsibility of doing something. Exactly here, if you have a blockchain network that's being deployed, you don't really have one organization who's deploying it and kind of taking the being the in charge of maintenance here, but a consortium would mean there are multiple stakeholders coming in, not just to participate in the blockchain, become a stakeholder in the blockchain, but they're also now trying to help and be a part in the maintenance and the deployment and all of those things. So just a little bit of knowledge there, nothing really important. And again, if you would want to ask the same question of if this is important to know if you're doing dApps, not really, just a little bit of FYI out there. Let's go. Now we are at wallets and transactions. I told you a little bit of wallets and transactions, but I'd want to now show you an example of wallets and also some transactions. Wallets, as you all know, the physical wallets that you carry help you manage physical assets that you have. Your physical assets could be, let's say, the cash that you carry on you, based on whatever currency you carry. It can be the cards that you carry, both credit and debit. It can be visiting cards that you probably have inside of your wallet. So any kind of assets, it's able to get you different slots where you can put all of this into and help you manage all of it. Similarly, there are wallets for blockchains as well, because we have cryptocurrencies involved. We already discussed that. There's always wallets, need for wallets, I would say. We will now go and visit and see what Solana wallet would look like on their playground. But before that, if you think of wallets or you think of your bank accounts, you have a couple of unique identifiers there for you. One of them is called your account number, which is a really big, yeah, it's supposed to be really big and unique identifier for you, which has to be public or which can be public. This is a number that you share to other folks if they would want to perform any transactions. If they would want to send you some money, you give them out that. But there's also another identifier, which is your PIN code, which has to be secretive. You cannot really share it with anybody else, because if somebody gets hold of your PIN codes or your I don't know what's an alternative name for that, but probably a 4 or 6 digit code that you have that you use to withdraw cash from your ATMs, let's say. If somebody gets hold of that, you are going to be broke. Similarly, in the case of crypto wallets, you have something known as the private key and the public key, I'm sorry. And that's self-explanatory. Public key is something that you can share with others. That's what they're going to use if they would want to send it to you. And private keys is something that you shouldn't share. We have another example of what should be kept secretive. That's UPI codes. You are correct. You should never share your UPI secret codes. I feel like Reserve Bank of India doing this, but that's correct. You shouldn't share that. I don't think unified payment interface is popular all across, but if you are in India, you've probably used UPI to pay. Now we are going to quickly go to Solana, and we're going to, I'm just Googling Solana, that gives me this, but we would want to go to Solana background, not background, playground, I'm sorry. And we are going to, for some reason, it always says French, which you cannot see. But anyway, we're going to look at what this is. I'm not going to explain what this is because this is definitely going to be taken care of by the Solana experts that are going to join you shortly. So you'll learn a lot of these things from them, but we're going to only look at the wallet that's hidden here. Let me get that into view. So if you see wallet written here, Oh, by the way, if you don't know what Solana Playground is, this is a way for you to write some code, experiment, learn, and all of those things without even having to set up things for you. But if you are trying to write any serious code, anything that you would want to push to production, you shouldn't be writing this here because, as far as I understand, this is a shared space. Your progress is never saved in here. So, this is just for you to experiment and learn, but never write serious code here. You should definitely set it up on your local machines, which I'm sure you will learn more of in the next session. And you can always go back and look at the documentation. So we're going to look at the wallet here, which tells me, oh, the first thing that you see here is the public key, which again, you know what it means. This, if you don't know SOL or Sol is the currency, cryptocurrency on the Solana blockchain. This is the balance that we have. It says 11.093 sols is what we have, and a list of transactions that have happened earlier, which again, like I said, this is a shared space, so there are people using it together. That's why you see all of these transactions happening, right? What we are going to try to do is we're just going to look at some transactions. That's just what we're going to do. You don't really need to worry about what I'm typing here, but I'll just tell you what I'm trying to do. We're trying to request the Solana blockchain to give us 2 more sols, and because this is a test network, whatever you see here carries no value, no monetary importance there. It's just for us to try out and things like that. So we can request as many as we want. It shouldn't be creating any trouble. I click on enter. Let's see. It says success, and boom, we saw it go from 11 to 13. So we now know that we were able to request it, and we saw the wallet in action. Now you'll also see that there's a signature that's passed that looks like a hash, which is trying to say that this is something that uniquely identifies this transaction that took place. Now what we're going to do is we're going to look at a lot of transactions just for the sake of it, to understand that there is something that gives us the transparency to view all the transactions. What I'm going to do is I'm going to copy this from here, and then you can either click on any of the links over here. I can just go to Solana Explorer, but by default when you click on any of the links here, it's actually taking you to an explorer of the transactions. But what we're going to do is we're going to search this public key to see what has happened in it, just for the sake of curiosity. So by default, when I clicked on it, it took me to the transaction homepage, tells me a lot about it, the timestamp, confirmation status, all of those things. Not going to worry about that. But what we're going to do is copy paste the account number of sorts, which was the public key, and then scroll down to see if anything here makes sense to us. So when we scroll down, we see a list of transactions that have happened, but we're going to only talk about what happened a minute ago, which looks like something that we tried doing. Let's click on the transaction, and we see this over here, which says there was an addition of 2 sols, which made the balance go all the way up to 13, which looks like something that we did. We requested for 2 additional cryptos or sols here, and then we had that go. That increased by a couple of sols. So I just wanted to introduce you to this explorer, which every blockchain, public blockchain will have, where you can just go copy paste, a public key, and you can get more details about it. You can copy paste the transaction signatures, all of those things, and get more idea of it. But what you need to understand here is while you're doing that, the public key is actually giving you a pseudo anonymity, which means that you are anonymous to someone who doesn't know what's happening, but they're at least now able to track that this is a unique public key, which means they're not able to track all the way up to you and say, hey, this was your public key, but they can now actually keep track of a particular public key and keep track of all the transactions that a particular public key or an account has been doing. But if, let's say, this was a case of complete anonymity, we would talk about a situation where your account numbers or your public key is also getting generated every time you do a transaction. Something that would be an ideal situation of completely anonymous or complete anonymity. But here, this is a pseudo anonymity because still there's a way to keep track of things, right? So that's about that. We just had to do a little bit of talking there. We're going to come back. I'm going to wait for 30 seconds here to see if you have any questions, because I know it's getting a little bit difficult to take in. But yes, I have questions. Okay, let's see. What's the difference between centralized app and private blockchain app? Okay, so while you're developing it, the name says, okay, you're talking about centralized and blockchain app. Okay, you mean an application that's not on blockchain? I guess that's what you're referring to when you say centralized app, and you're talking about a private app. Cool. um, a private blockchain app, I would say, is one wherein you want to keep it restricted to certain amount of people. Let me give you an example. Let's say three companies today want to come together and want to perform some kind of a transaction between them, and they would want to essentially have a contract put in place. Contract is again a term which is very specific to one of the blockchain platforms, but just let's just use that for this case, wherein we would say that, hey, three organizations or three companies would want to get together and do something wherein they would want only people from these three organizations to join this network and be able to communicate using the application or the decentralized application that you build, which is going to be the interface for the end user. So that's a use case for private blockchains where you don't have anybody from anywhere coming in and joining, right? Now, talking about centralized applications in general is what we saw in the first slide, the first couple of slides, where it's a common case of one server, a lot of clients communicating to one different to the same server essentially, and then if that server is unable to take requests for some reason, crashes, fails, your entire network falls. I hope I was able to explain that. That's what I could think of based on your question. Let's pick another one. In centralized, all your data go to one database, whereas in blockchain data is decentralized. That is also correct. How much depth knowledge in Rust is required for learning Solana? I might not be the right person to ask that. You should probably save that question for the next stream that's coming up with the Solana folks. They'll be able to tell you that because I don't really know a lot about Solana. Cool. We will now go ahead and look at what's next. We're almost at the end, I see. We briefly mentioned about this paper, this Bitcoin paper by Satoshi. I don't know if you have heard of this name, but this is again a completely anonymous name that we've heard of, Satoshi Nakamoto. We don't know who that is, but this person apparently released a white paper, a research paper of sorts, which explains blockchain, but we've never been able to track what it is. And guess what? While we were discussing of a lot of things, we actually covered a lot of basic terms that you would need to understand, which is in that paper in a very short period of time. So pat yourselves because you've done an amazing job understanding a lot of things. But let me just show you how you can find that paper and some terms that we've already discussed. But a disclaimer here that there's a lot more of mathematics involved in some parts of the paper, but you can completely ignore that and read through the parts that make sense to you for whatever reason. If you'd want to just do that out of curiosity, if you'd want to develop any kind of applications, this is definitely going to be a very big addition to your knowledge of computer science. So I'd highly recommend you do that. Let me just show you how you're going to find that. And here I'm also going to drop some Google search tips, which I thought would be really helpful. So we're going to look at what should we start with searching. So let's just say we don't know what it's called. We're just going to type Bitcoin and you're going to look at the results. And this is definitely not what I wanted to read about. Now we're going to type Satoshi and paper. Oh, this was easy. We did not have to do a lot of things to figure this out. I'll just quickly show you what these things are, and then we'll discuss of some of the Google tips that I would want to give you. So this is a paper which has an abstract. It's called a peer-to-peer electronic cash system because this paper, I believe, was completely based on setting up a crypto network of sort or introducing a cryptocurrency. And of course, this is the first blockchain platform that everybody came to know of existence. Looking at, just scrolling down randomly to tell you what did we do. We talked about transactions, we talked about hashing, you heard me a little bit about signature, but there's probably some more that you need to hear of. We did private keys, blocks, items, hash, yes, proof of work, a little bit of that. We talked about nonce, previous hashes. We will look into why previous hashes is required next. And yes, a little bit of all of these things, hashes, getting together, all of that. So you should definitely do that. Which reminds me, we should now definitely go back and check our demo of the blockchain together. So, if you remember, we'd skip this because we wanted to explore more. But let's not talk about two important things. One, what is cryptography and what does that have to do with blockchains? Now, what we're going to do is this is a very simple interface where you have data, you have previous hash, you have a hash, you have timestamps, you have 604. This, in case if you don't understand, this is the nonce here. They've not written it explicitly, but they would want you to identify this as the nonce. And Genesis block indicates that this is the first block that's gotten created when you started a blockchain network. So just a addition here that whenever you have a new blockchain network spinning up, the first block is always called the Genesis block. Now, to understand why we would need previous and next hash, we're going to create random uh, blocks over here. So let's start with, I'm just picking up names from the chat. I'll say block one is for raw 2710. Add new block. We see another block was created. Oops, we will let that go for now. And then we will go create one for it's an issue. And then we'll say there's another one for Anshi 56. I think that should be enough for this demo. So we have these many blocks created. We are at block number 4, while we have not counted the Genesis block yet. So counting the Genesis block, we have 5 blocks now. Now what we're going to do is, we notice there's always an error if you try to play around with the data mentioned over here. And of course, all of these green things should turn to red. That's what you should be able to guess based on the demo we've seen earlier. But let's see how that affects the rest of the blockchain if you do that. Because we created 2 blocks for raw 2710, we're going to change this and say block 1 is not for raw 2710. And you notice it's not just this block which turned red, but all the blocks that followed it now turn red. Let's understand why that happened. And you also see that the nonce has disappeared, and you see this button appear, which stands for mine, which when you click it will mine the blocks. We kind of know what mining is. We would want to look for a nonce that would help us reach the target hash and all of those things. But now, to actually understand why we say that these blocks in a blockchain are cryptographically connected and why these hashes are important, let's dive in and check what happened. So the first block, um, or let's talk about the Genesis block first. So the Genesis block, because it did not have any block before it, the previous block hash is completely zero, and there is a hash for itself. Now, if you notice, the first block here, which was for raw 2710, has the previous hash, which is equal to the hash of the Genesis block, and then hash for itself. Now, this block, which was not for raw 2710, has a previous hash, which works completely fine. But when we try to edit the data over here, that messed up the hash of this present block. Now, thinking of it logically, because every block has a previous hash and a present hash, if you by any chance do anything wrong that will tamper the hash of a particular block, all of the blocks after it will also get messed up. And that's what we see here. And that's how we say blockchains or blocks inside a blockchain are cryptographically connected, which means they are connected by the means of hashes. And that's the thumb rule here. So every time you see something of this sort happen, you should know that there's something wrong going on, or there's some probably a mischievous activity or a mischievous player in your network which is who's trying to do something. But in an ideal case, you shouldn't be mining it directly to fix all of the things. You should now go investigate, figure out what went wrong on all of those things. But because this is just a demo, we're going to click on the mine button here and make it all green. Yay, we have a perfectly green blockchain back with us. I'm going to take a pause here to understand if you now understand the concept of hashes and cryptographical linking inside of blocks, and then be probably towards the end of the session as well. Going back to the slides. Anybody has any questions, any thoughts? You think this is getting complicated, even if I promised this would be beginner friendly? Anything of that sort? Would want to share anything interesting? Are you all with me? Too complicated to digest? Yes, I got one yes. I see Vinayak being happy about his block, but lost one later.
I don't know what you mean by I see. How about
I just had my Siri go crazy when I said something. I don't know how that got activated. And then I have another yes, 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 good to go. Great. Cool. Now, to deviate a little bit from what we've been talking about, let's just go do some Googling and see how we can improve it. So, um, these are some things that you probably know of, but we're going to do some bit of Googling and figure out how to improve it. So, let's just say I want to look at a lot of research papers for a particular term. We have a question here. Now, what's next to learn in blockchain? If let's suppose I understood all those three slides, if you already know of what all of these things mean, you are probably good to go and specifically concentrate on one of the blockchain platforms, and then obviously go ahead and start coding on them. And these platforms come with a specific language that they require you to learn, so you probably will have to start there. But coming here, let's say I am only looking at blockchain and I would want to have all the blockchain papers listed down. But if when I write these things, it's not really leading me to papers. But my knowledge of Googling tells me that these websites or papers or research papers that I'm going to find will always be, or most probably be, in a PDF file type, right? So a way to do that and to force your results to always be of a particular file type, you can use, oh, let me just zoom in. You can always use this keyword called file type. Now, if I want to look at things which are probably blockchain papers and PDF file type, I will hit enter, and you see a lot of papers by different people coming up, and all of that points to PDFs. And this is probably the most simple thing that you could do, and you probably knew of it. Let's say you were looking to, um, what do we take as an example here? Okay, let's just say I wanted to look for blockchain papers on a specific website. And I don't know if you all know of this website, but this is a very good place for any kind of research papers. I think both published and unpublished would find a place here. And this is pronounced archive.org. So what we're going to do is we're going to look for blockchain papers only in this website. So what you could do is type down site colon, type down archive and .org. And you're going to find all of the PDFs that have blockchain, that have resemblance with blockchain papers from the same website. Isn't that cool? Let's take a step forward. We now know that the blockchain paper, the Bitcoin paper that we were reading, was called a peer-to-peer electronic something, right? So we're going to write what we know and have Google search fill out the rest of it. So we're going to say peer to peer. We already have that in the suggestions, but we're going to ignore that for now. We're going to say peer to peer. I don't know what the next word was, so I'm going to put an asterisk here, and then I'm going to say cache, something like that. I'm going to press enter, and boom, we have that on the first. Not because it's a super popular paper, but I'll tell you how this works. So let's just not consider the asterisk for now. What happens is when you have quotes outside of whatever you're trying to write, a phrase essentially, Google search is trying to find an exact match for whatever you have written. So let's just say let's pick up some lines from Hotel California lyrics. I can pick up something which is very generic. So let's say it says you can find it here. I pick that. I have quotes here. I look for you can find it here. Click enter. It's always looking for exact matches. So wherever you have, I have a dark theme here, so you probably cannot figure out that it's in bold. But all of the places that it was able to figure out that phrase as a direct match will all pop up together, and then you can go ahead and have it more streamlined with the link and the file type and all of those things. Now what we did here was, of course we have quotes outside, so it means that we're looking for an exact match, but we're also telling the search engine that we're not sure of what term is here in between. This is probably a case where you listen to a song at a cafe and you probably know of some words here and there, but you don't know with all of the words, right? So write down what you remember, put an asterisk in between. The asterisk denotes that the search engine can fill in any word over there, but the rest of it is absolutely going to be that 100%. If you're not sure of the rest of the words as well, remove these quotes and tell the search engine that it's not an exact match that I'm looking for. Press enter and you will definitely have what you're looking for. Isn't that cool? One last thing that comes to my mind right now is let's search for Mustang. And while we search for Mustang, I am 100% sure all of you are reminded of the car Mustang. But let me tell you, Mustang is probably also related to horses. Let's find out. So, what I want to do is, I want all the searches related to Mustang, but I do not want anything that's related to cars. So what I do is I have an hyphen here, which is followed by car, which essentially says, give me all that you can give me based on the word Mustang, but preferably keep aside everything that has any relationship with cars. Let's see how that goes. I press enter. The images, of course, do not work there because they probably have an alternate text which is completely different, and this will not work on images. But if we scroll down, you will see the cars have almost vanished. It says why Mustang is famous in Nepal is a place apparently. Cool. Netflix have Mustang. We are sure it's not a car. We got one car reference, two car reference, which is I think okay. We got a film which is called Mustang, a district film again, a lot of different things. So this is how you would want to remove some of your searches while you're trying to get something out of there. So if I would want to remove everything from Avalanche that we were trying to Google earlier, and I don't want anything related to cryptography to appear, I will have everything else appear here. I hope some of this is helpful for you guys. I thought I should let you know, but that's how you would want to Google and make things easier for you. I realized that I stopped sharing. Let me go back and do that. Give me a second. But while I'm doing that, would you want to share any thoughts? Did you know of this already? Or did you find anything new from what we have discussed? Anything you'd like to share? Anything you've tried out in the past? Anything else that you know of searches? Any commands that we missed out that you'd want to share with other folks here? Looking at the chat, I see a no. I don't know what that means. I don't know if that was a no for no, I already knew this, or no, I did not know. We have another person saying, this is great, I did not know this. Oh, I'm glad I was able to help. I have my screen back. Yes, I do. No, I did not know, but this is cool. Great, great. I'm glad I was able to help. Last couple of slides here. We're going to talk quickly about, we have time. That's great. We're going to talk about fungible and non-fungible tokens. I know all of us have heard of NFTs and fungible tokens, non-fungible, both for good and bad reasons. Let's understand what these are, and we'll not talk about the hype around it and things like that, but we're just going to discuss what these things mean. So fungible tokens are not unique. They're identical, divisible, and can work like a currency. So if I want to give you an example of what fungible is, fungible tokens are your currencies. So any kind of cryptocurrencies, any kind of fiat currency that you carry in your physical wallets, all of that is fungible. Non-fungible is something that's going to be 100% unique and probably will have only one owner. You might have seen a lot of NFTs on the internet, which are images completely, completely unique, does have only one owner. So there's always something specific about them. And that's where the logic of fungible and non-fungible comes into picture. I just wanted to mention that there. Moving on, one last term here, which is called decentralized autonomous organizations. You might have heard of DAOs. DAOs, as the name suggests, is an organization which is decentralized. Both of those terms should make a little bit of sense to you, wherein it says it's not centralized, wherein it's not, that it doesn't have a single authority controlling it. There are probably more number of authorities that are involved in the decision making process, and it's an organization. And to your surprise, I want to tell you that this is also emerging to be a legal structure at some places. So we've known of LLCs, LLPs, private limited, all of those registrations for companies. B Corp, B Corp is what MLH is. DAOs are also are being accepted at some places in the world as uh, a legal way of forming companies or organizations. Wyoming or Wyoming, I think Wyoming is how you would call it, is a state in the United States that has laws that would accept DAOs as legal entities, which is actually cool. Finally, some misconceptions about blockchain. Blockchain can be used to store data. Well, both yes and no. We did see that we were able to store data which will have a lot of metadata in it, block numbers, hashes, transactions. All of those are of course data that you're trying to store here. But is it really um, recommended that you store files in it? I would say no. But there is a way to store files on the chain or off the chain. Those are two terms that we're going to discuss. On the chain means that you're trying to put in your data in some way into the blocks and the blockchain essentially. But because blockchains are definitely slower, and if you've been watching the stream earlier by Solana Expert yesterday, you would also have seen them admit that blockchains are slow. So you'd want to make sure that you're not contributing to make it even more slower. What you're trying to do here is you're going to have only hashes of some of these files being stored in it, and you'll have the file stored at a completely different place. So there are websites, or there are places called IPFS, technologies called IPFS, and a lot of those things. I wouldn't go into a lot of detail there, but if you'd want to check out, I just put that name here, look for IPFS and related technologies. I hope I spelled everything correctly. Yes, looks good. We also got to understand that blockchain is not cryptocurrency. Blockchain is not Bitcoin, but blockchain and Bitcoin are different things. But Bitcoin is an app, is a thing that's on blockchain, but it doesn't really mean the same. You can't really use the words interchangeably. And there's also a misconception that blockchain can only be relevant in the world of finance for financial application, which is definitely not that case. To actually go ahead and check where we can find, oh, we have an interesting comment here. Jay says the second misconception, pretty much why I used to have a dislike for anything blockchain. I would say you're not the only one. That does happen, but I hope you now know a little bit more of what things are and how things are not what you assumed it to be. I'm glad that I was able to help you understand those things. You should definitely go check more about anything that comes your way, I would say, just out of curiosity, so it gives you more knowledge of what you're getting into, because computer science is a vast sea that you'll need to go to and learn more about. Now we're going to look at some interesting cases both from the world of finance and outside of it. So I will have to show you other tabs. Let me just go open this. So this, what you see on your page, on your screens, is called Gitcoin. Most of you might have already heard of Gitcoins. I'll just scroll down to show you what this looks like. Also some amount of open source lingo there. So yeah, something I would like. So Gitcoin lets you launch a grants program, which is basically you using uh, a platform to have a lot of funding for yourself, and that's exactly what open source would also need. Open source doesn't have fund coming in by default, so a lot of open source maintainers set out a grants program on Gitcoin and then have a lot of people sponsor their work and then continue to do the awesome work that they do. So you should definitely check this out. The second one I would want to show you, which is loading, is called Everledger, and this surprisingly is something I did not know of. And they have a lot of other solutions, but this was one. This was one that I would wanted to point it out. Everledger surprisingly works with tracking and validating authenticity of diamonds using blockchains, which is very, very surprising. So what I can imagine they might be doing is they're trying to have a lot of data about a particular diamond, which I don't know of. They probably have a lot of unique characteristics, these diamonds that they put into, and then whenever there's somebody who's coming to check the validity of it, they have a way to look at that, which is so cool. I never thought that can be a way to do that. Next up is something called as SyncFab. SyncFab is using blockchain for supply chain traceability. So this is also called asset management. Let's say I am shipping something. Let's say I'm an e-commerce website that you're buying something from. I ship something from a place X. It reaches your place Y, and there's a lot of intermediates in between. There's X1, X2, X3, X4, and it reaches you as Y. And I'd want to trace every part of what happens and make sure there's no tampering that happens in the process of this getting shipped. A lot of those things, right? So these folks are using that, is what I understand, is are trying to achieve that based on a blockchain platform. One more here, this is called Block Pharma. This is kind of similar, and I don't know which language this is, but what I can understand based out of it is they're using this platform to again do some kind of SN tracking and traceability, but for drugs in this case. So medicines and drugs, they're able to trace them and also fight against any kind of counterfeiting. They're able to validate and authenticate the value and the validity of drugs, I would say. That's again another cool thing to do. And guess what? We did it. That was all that I had to share today. We had an awesome journey. Thank you for everybody who stuck till the end. But of course, because you decided to stick till the end, there's always a reward coming your way. Let me check the time. We do have some time left. We will probably do a Q&A while we are doing this activity. But if you have any questions, feel free to drop it. I'll definitely pick that up from there. But what we're going to do next is we're going to play a game, or we're going to do an activity which is called Let's Design NFTs. No, you're not going to write code to get your NFTs up, but our normal knowledge of NFTs that we have right now will actually tell us that this might be something related to art or generating something that I can use as an NFT. If that's what you thought of, you're absolutely correct. I will quickly show you what we're going to do, and we're going to time this. This is going to be a competition, and then we're going to rate each other's artwork while we are doing it. We will go to a link which I'm going to share very shortly. So, shout out to Stable Diffusion, again, another open source project. I'll drop the link very soon. So, if you remember, I talked about OpenAI while we're looking at ChatGPT. This again is, I would say, an open source alternative to the DALI model that OpenAI has, wherein you can just enter a prompt, click on generate images. Let's show you what it can do. I say monkey in a space suit, and I click on generate image. It takes a little bit of time to process, and then by default, I think it's going to show you 4 images based on the prompt you wrote. And this is only based on the prompt that you wrote, which is very, very cool. So what we're going to do here is we're going to generate art for ourselves. We're going to call them NFTs, and we're going to share them to the Global Hack Week Lounge channel on Discord, which all of you, I think, already know of. You're going to drop your artwork there, but before you begin, I'm going to share this link first, and there's also something that we're going to do over this, which is we will all decide on a particular term or a custom element that we would need everybody to include in their artwork. And based on everybody's artwork, we'll first verify if that custom element is in fact present inside that artwork, and then we'll go about rating it. If you don't have that, or if you do not manage to get that, there are chances you might get disqualified. So do you want to give me ideas of what that custom element can be? I know there are a lot of Blahaj fans here, but unfortunately Blahaj is not something that Stable Diffusion understands. I did try that out yesterday. So we're going to probably have to look for other custom elements that we would want to have. Anything that you can see around you, anything that you came across yesterday, today, anything that's very close to you, drop those things on the chat, and then we're going to select one custom element for everybody to generate. Looking at the chat while I grab some water. I see a question for attendance link. I'm going to drop the link to check in. This was your link to check in. You should have it. Uh, are there folks listening? Do you have any custom elements that you'd want to add? While we decide on that, I'm going to drop the link to the Stable Diffusion playground. I'm surprised you've run out of ideas because I always thought the MLH community is very, very, very creative. Let's come up with something that we can include. It can be anything for that matter. It doesn't have to be anything complicated. Any object that you can think of. Like in this case, I had monkey in a spacesuit. If we would want to have spacesuit as the custom element, we can just go about generating random things along with a spacesuit. And spacesuit can be a custom element here. What do you all think? Do you have any suggestions there? Um, okay, I see Nishit saying swim in water. Okay. Um, I would still look for elephants swimming in water. Okay. So what you suggested was the whole text prompt. I would say if you'd want to pick up a custom element, your custom element here would be water or swim or elephant. So what we'll do is we'll have everybody put up swim or water or kites for that matter. I am seeing a lot more suggestions come in. We'll have everybody put that word in their prompts, and then we'll have everybody sharing one screenshot from the four images that they generate on Discord, and then we're going to rate it. I like kites. I definitely like kites. Water or swim or elephant will also be a good suggestion. Any more ideas? I'll wait for one more minute here. Sky. I have sky as another element. Sky and kites. I think that's where you're deriving this inspiration from. White hole near Earth. That's again a phrase you'd probably want to have just white or Earth or things like that. But I really like kites. How about we stick to kites then? So what all of us are going to do is everybody who's watching the stream, we also have mermaid, which is another good thing. Oh, I feel we probably can stick to kites for now. What we're going to do is I'm going to send this link in the chat, and you know what to do while you're on this link. You're going to this page, you're going to press get started for free. You're going to put any prompt here. Oh, I did click on something which I shouldn't have. Okay, you type a prompt here, and the prompt should also have kites. So your final image will have a kite somewhere in that frame. You can use a creativity of what you would want that kite to do, where you would want to fit it. That is on you. Once you have that, we're going to go back to the Global Hack Week Lounge channel and drop all of your or all of our art that we generated, and then we're going to quickly rate what we did. Right. I'm going to drop the link over here. Looking at the clock, I can see the time here. It's about 9:15 p.m. IST. All of your times start right now, and we will wait. Hey Jay, that was great having you. Thank you so much. By the way, there's also swag giveaway happening with this activity. If you don't want to stick for some more time, we will have all of you generate this till 9:20 p.m., which is 5 minutes to generate whatever you would want to. And then you can go about dropping it on that channel. We'll quickly go around everybody's art, vote for it, and then we'll call it a day. I am going now to share what we would want to share, which is Discord here. Let me go back. I hope all of you have started generating. Yes, that is correct. Kite should be in your picture, and you would get kites in your picture when you have kites as a word in the prompt that you give Stable Diffusion. I hope you understand that. Let's get the channel. Let's go, let's go. I don't see anything up yet. But I'm going to share my screen so we all can look at Discord. And for some reason, I don't see Discord. Should I be worried? You can post on, okay, let me just clarify this. You can post on the channel which says Global Hack Week launch on the MLH Discord. Let me quickly share my screen and show you where this is. Sharing screen, going to Discord. You will find a channel under Global Hack Week December, which says Global Hack Week launch, where I can see a lot of resources being shared already. Drop your images here and let's get started with voting. I can see Nishit is typing, cat in space. Nishit, you also had to include kites, which is something you missed out. Kites is the custom element. You can also now go back, create another art which has kites in it because there are 3 more minutes. Let's go, let's go. Looking at the chat for a moment. No questions. We're good to go. Waiting, waiting. I can see someone's typing. Can see a couple of folks are typing. Oh, we have a really cute picture, but we don't have kites here. We have a boy with a kite. This looks amazing. I can't believe this is an AI that got it, but really, really, really good. Um, this person who shared cats, you might want to have kites also somewhere. I'm not sure if you did include that, but I don't see that anywhere. Um, we have someone who shared an image with a different extension. Would you want to maybe click a screenshot and have it shared as a PNG or a JPEG so it's easier for us to load? We are almost at time. Let's go. I'm going to try to set this up. Meanwhile, let's see if we are able to get this fixed. I'm going to stop sharing. I don't know where to send. I'm not in that group in Discord. Whichever group you are in, can you, whichever channel that you can see right now, can you post it there and tag me? My handle is Siddharth at MLH. Usually, we don't encourage tagging MLHs directly, but for this specific activity, you can just go ahead and tag me, Siddharth from MLH, directly and send your image. I'll consider that. Oh, we have a lot more of them coming in. Let me share my screen. This looks really great. We will wait for 1 more minute and then I'll go ahead, share my screen, and then we'll decide on the winner. While we are deciding on the winner, I will have a reaction on all of the entries, and you can go ahead and vote for whichever you think is the best among the ones that we have. We have 1, 2, 3, 4, and 5 entries for now. Go click on whichever you like, and we will have a winner soon. We're out of time, but I'll give you another minute. Another question: how to tag you? I'm assuming you're already on MLH community Discord. While you are there, you can just drop the picture on a channel and then @ Siddharth. You should see my name, and the name should say Siddharth at or from MLH. I think that's what I have as a name there. Just drop it somewhere and then tag me there. I should be able to see it. Interesting, but I see there's nobody voting for other folks. Let's go vote. We are out of time, so I'm going to quickly share my screen. I think you should be able to see it now. Yes. So we do vote for this one. This doesn't have kites, but because this is super cute, we're going to consider this. So if you think this is really, really, really cute, go ahead and vote for this. Then we have a boy with a kite. This looks very interesting. Good job there. Let's see who voted for it. Oh, Nishid voted for himself. And then we have F1, Formula One cars with kites. Interesting. I wonder if that would make them fly. Looking at a lot of kites together, I wonder what the prompt was here. This looks nice. I'm surprised to see what the AI can generate. Here is my space kites. Oh, wow. I like the use of words there and I like what it produced. Really, really cool. I think that we don't have people voting. So I am probably going to select a winner from the ones I see. And I think for the most amount of creativity that's gone into, I would say, let's see, I'm going to stop my screen and I'm going to announce the results here in the chat. I also see there's someone who's uploaded it in Global Hack Week chat or general chat, maybe. Um, for some reason, I cannot find anything with the name Global Hack Week chat. I'm not sure if I'm looking at the right place, but I'm now going to drop the Discord ID of the one I like the most. And what you have to do is take a screenshot of the message that I'm going to drop and create a ticket on the MLH Discord using the channel Globe MLH support tickets, and you have swag giveaways coming your way. Let me quickly note down that name here, and then here's our winner. Congratulations, that was an amazing use of words, which is what I thought. And what you're going to do now is, if you are here watching the stream, you can take a screenshot of this, create a ticket on MLH, and just say that you've been chosen for the giveaway for the stream blockchain as a piece of cake. And somebody from the team will get back to you very, very soon to get more details for your swag. Congratulations. And for everybody else who joined, there are random giveaways that happen for every stream here, so you can definitely come around and get swags on another stream. Just one last thing that I would want to share here before we call it a day. Let me go share my screen again. I think I did a good job for the first time that I'm using StreamYard, so I'm definitely proud of that. We did this. We had amazing results come out of our Let's Design NFTs. And what I wanted to talk to you about was, if you are now interested in blockchain and if you're really, really curious to build hacks, learn more, and all of those things, we have a digital hackathon hosted by MLS Digital Hackathon coming very soon, which is on the 9th, which is this weekend. But unfortunately, this is only for the APAC region. So if you're a hacker from the APAC region who want to learn more, we have workshops lined up for you. You should definitely come in and register to this event. I will drop the link to this event. I hope to see all of you there. And if you like this mini event that we did right now, the design NFT game, we're going to do that again with a lot more interesting turns to it. So if you'd want to stick around and come play, even if you're not hacking that weekend, I would definitely love to see you around. That is all from me today. Thank you so much for joining. I had so much fun talking to all of you, and I hope you had a very good time listening to me as well. And you will definitely have a lot of fun for the rest of the week with Global Hack Week. Me signing off. Happy hacking. Bye bye.